All right, I'm changing directions today. I'm going to the second part of the course title. The first part of the course title is microcontrollers, and now I'm going to talk a little bit about interfacing. All right, that's there. And I'm planning a lab for next week, right there. So next week it's going to be the half of you show up at 12, the other half show up at 3 o'clock routine, that there. Today I'm probably just going to do 2 lectures, but I'm going to just do them kind of back to back right there. That way we don't have to come back at 3 o'clock. So if about an hour or so into the lecture, people want to take like a 10-minute break, we can do that, and then come back and do the second hour. That there. So the first half of the lecture, I'm going to talk about interfacing a keypad, and that'll be the lab for next week. The second half of the lecture, I'm going to talk about interfacing the LCD. Unfortunately, I will tell you that we tried doing an LCD lab last time at there. I taught this class there. Unfortunately, our 8051 boards that we're using only have a 3.3 volt supply available, and the LCD requires 5. And given the number of boards we've got at their lab stations, trying to find 24, there's 3, 6, 9, 12, 24 5 volt supplies is somewhat difficult. So what I will most likely do is the week after the semester break, I will do a demo lab where I use the Arduino board, which does have a 5 volt supply for it, that there, and show how the LCD works. That there, the code will be different for the Arduino, but I'll do that the week after the semester break, right there. So the lab for the 8051 you'll need to turn in so I can put together a grade for that there. We have so many graded labs, and I'm going to make that our first graded lab right there. So I don't think you submitted anything for a grade so far, have you? That's there. I don't remember anything being turned in for a grade. So at least for near the first half of the semester, I have to have 1 graded lab. So I'm going to do the one next week. That there. So first off, let me explain a little bit about. Let me get my pen. You know what? I really can't write on this right here. Let me see if I can do a Control-A, Control-C, and sometimes this works, sometimes it doesn't. That there. I'm going to try to copy this into OneNote. Right there. And it did not work because it didn't take the picture. So, all right, well, we will delete that there. All right, I'll just have to talk about this and use the mouse that there in my discussion. Okay, this is very similar to the keypads that we've got right there. So that there, in terms of wiring and the connection, I didn't bring the keypad, but you'll get plenty of chance next Friday or Thursday to play with this right here. That there. But the wiring on this right here, when we look at the keypad, and again, I can't write on this, but I can do this here. We've got 4 rows right here. These are our 4 rows, and these are our 4 columns right there. So a particular key is, for example, this key right here, if we look at our keypad, is the number 1. So this is the number 1. When I press this key, I generate a short between column 1 and row 1 right there. I generate a short between those 2 right there. And actually, copy image. I think I can just, okay. All right, now I can write on that there. So, okay. When we look at that there, and let me also go back and grab copy image and put that underneath here. So, right there. So, right there. So what we essentially do in our keypad interfacing is we look for a short between two 2 that there. When I push this button here, for example, I create a short between column 2, right here's column 2, and row 2, right there. So I know that I've made a push the button labeled 5 on the keypad. So our software has to go through and take a row or column high and then look for there. So what we basically do is we tie one of these rows to our BCC here, and then right there, and we take this row high, we take this one high, and then we take the rest of these low right there. If we see when we push this that button that this one won't be high, but next we take this one high, and then we look for a short there. So we basically go through and we take one row column high at a time, and we look for a high on one of the pins right there, excuse me, the way I wired this here, we look for a low. We take this one, we take one at a time, low or high. That there. If we take this one low, everything else will be high because we have our pull-up resistor right there. That there. So essentially, what we're doing is we have to set up a scan routine, which will go through and take one of these high or low at a time, and we'll see how this software works here. We'll just use this software for our lab. That's there, and this software does work. I've done it 3-4 times since I've been here at UNKL, and I've done it multiple times back at my old university. So this software actually works pretty well right there. So when we look at our, and that's not my bike, by the way. It's a nice color, though, isn't it? Only the guys can appreciate that. Let me. That there. I got a blue one. That there. So mine's blue. I do ride a Vespa. That there. So okay. As we look at this right here, this is basically here. We have 16 pins. This is a 4x4 matrix right there. Is what this is. You can get keypads 4x4, 5x5, 4x10, all various types of matrices. The most common is the 4x4. And the reason the 4x4 is most common is that, the original 3x4 was the old telephone keypad right there. And we've added A, B, C, D for the fourth row right there. We don't have an E or F key. So actually we use this for the E and this for the F right there. So that there, or we can, that there. The only thing we're going to do for the lab is see that we can press a key and recognize the key press right there. So as we look at this here, a logic low is applied row that there. Here they're saying, we can read the status here. The status of each key is processed. For sake, we will assume that all column pins are connected to input pins and all row pins are connected to outputs of the microcontroller. So this is telling us that we're going to read the columns and we're going to output to the rows. So it's the opposite of what I just said right there. What I just said a few minutes ago is that we're going to, let me go back to here, right here, is that here we're going to connect the columns to our inputs right there and our rows to our outputs. So what I said a few minutes ago was wrong. We're going to be connecting these to our, these go to the microcontroller as right there. So the microcontroller is going to output either a high or low to that pin right there. And then it's going to only do one of them at a time, and we're going to read these pins that there to see whether they're high or low right there. So we have to go through a looping operation right there. We keep taking these all high, and then we read to see if any of these are low or high, depending on how it's wired, and we'll see how this one's wired as I go through the explanation that there. I'll be honest, I did not read this website just before I went before I came to class, so I don't remember how they did it. That there, you can do it 2 different ways. Actually, you can do it 4 different ways, but one of the 2 ways is where we tie our outputs and our pins. So this is our output from the microcontroller, and these are our inputs to the microcontroller right there. So we need 8 pins to control this keypad right there. Right there. So each column is scanned. If any switch is pressed, it's pulled low. So we write low to it right there. So again, what we're doing is we're going to write high to rows 1. All the others are going to be pulled high. So we write 1 or 0 0 or 1 1 1 0. And then we press a button. If a button in the first row shows a 0, then that button's been pressed. If it shows a high, that means that button has not been pressed right there. Because if we don't put the short between these 2 pins, for example, right here, we don't put a short here. So we're going to put a low. The example here is this is going to be a high, this is going to be a low, this will be a high, this will be a high. And then if this shows as a low, that means that this button has been pressed right there. So we're looking for a low moving that there. Or now, if this one happens to be low, then this button's been pressed. Now we can only recognize 1 key press at a time, right there. So in the way that this works, it's going to stop at the first low. If it sees 2, we ignore it, right there. Or we only recognize the first one, right there. You can write the code, and it's a little bit more difficult code. If there's 2 lows, we just ignore it, right there. We assume somebody's pressing 2 buttons. We don't know which one's the right one, so we just ignore it until they only press 1. I think this software will recognize 1 of the keys and ignore the other key. So it depends on how complicated you want the software that there. I'm not going to rewrite the software that there for the 2-button lockout. They call it 2-button lockout. So okay. So this is the connection that this particular author used. Now you notice that he's using port 1 right there. And right there, copy image. Copy image right there. That's there. So paste image right there. And that didn't work. Right there. Copy image. It worked a minute ago. And it's not going to work this time. Okay. So we have no choice but just to talk to this right here. So you'll notice here that he's got his first 4 rows tied to port 1.0, port 1.1, port 1.2, port 1.3. And we may switch that next week depending. I have to look at the board. I think we can use that. If one of the LEDs happens to be on one of those, we may have to switch to port 0 right there. So we may have to switch to port 0 for the lab right there, which means we change the code just a little bit right there. But we're using 1 port that there. Now ports 1, 0, and 2 on the 8051 are bit addressable, so we can split them into 2 right there and have half the port be input, half the port be output right there. So that's fairly straightforward right there. So also note that we have there's an internal pull up on the 8051. That's why we don't have to have it that they're closed right there. You know, I showed in my example here a few minutes ago this pull up right here. I talked about this pull up or somewhere. Someone forgot to turn their phone off out there. That's punishable by standing in the rain when it starts raining. So whoever's phone is, if it starts raining, you gotta go stand outside for 10 minutes. That there, you get wet. That there. So you gotta come up with a non-painful punishment. That there. So okay, inside the 8051, right there. On any input pin, there's a pull-up resistor right there. So if we don't tie that pin low, that pin-up will read as a high if it's left to float right there. And the reason, and because of that internal pull-up, we don't have to put the external pull-ups that there. If you did this with another microcontroller, you might have to use an external pull-up resistor right there. So that's there. And as we go through here, the 8051 will provide the power on it. This talks about that we don't have this circuitry right here because we don't bother. We use the internal clock on that there. So this all is not part of our circuit. That there, we will talk about this the second half. This is the LCD connection right there. So we'll talk about that. I'm concentrating on just this corner right here in this hour right here. So that there, this talks about that there, and I'll put this link to this website on Facebook at the end of the hour right there. This is our code right there, and I'm going to go through and talk predominantly about the code here. The first part of this code here we're not going to talk about. That's the second half of the lecture. That's the LCD connection right there, and that's for over here right there. The second half here, these are our keypad connections. So what we've done here is that this is our 8 keypad connectors right there. And as I said, we're connecting row 1 to port 1.0, row 2 to port 1.1, port 3 to 1.2, and port 4 to row 4 to port 1.3. And there are 4 columns are connected to 4, 5, 6, and 7 right there. So that's our connections. We have a couple of functions here that are not necessarily used in this particular lab, other than we have a delay for debounce is what we have the delay for, in order to, when we press a button on a keypad, typically you'll see something like this. If it's going to go from high to low, it's going to go like this right there. This is called debounce, because when you press that button, it doesn't close immediately. It closes after a little bit of bounce. You're going to have to find chairs or something that there, or sit on the desk. I don't know what to do. Tell you to do that there. Yeah, that there. So, but that delay is used that there, and we just call the delay later on. And all this is just a 4-next loop right there. This is just a delay. We could use the same delay that we used earlier. That there. All right, this is our read keypad right here. And notice that the first thing we do, and we just repeat this code. This is actually very simple code right there. Is this code right here is we're going to set all 4 columns to a 1. On the 8051, if we want to read a port, we set it to a 1. And if it's taken low, then when we read it, it will read a low right there. Now we may have to do something. I think we're only a week from the semester break. The class is starting to get giddy, right? That there, you're looking forward to going home and eating mother's cookie, right? That there. All right. So this is the heart of the code. It's very simple to understand. Right there is that we've got 4 columns. We take them all high, and when we take these high, that makes them an input. Right there. The 8051 is very simple on reading ports. In order to make an port an input pin, or make a pin an input pin, all we do is just write a 1 to it, and if the input is floating, it's a 1. If the input is a 1, it's a 1, and if the input is low, it's going to be a low, right there. So remember, there's an internal pull-up resistor right there. So our 4 columns are inputs right there, and that's why that's there. And if I could write, I would write the word input there. So then we take the first row low right there. We make the other 3 rows high right there. And then all we do here is we have 4 lines right there. And what we're doing here is we're looking at these 4 lines, and we're saying if column 1 is a low, We have a delay for the debounce, to cover for the debounce time, in order to let the switch settle down. And if it's still a low, right there, then we return a 7 from our function, right there. So this is a function called reKeyPad, right there. Right there. So we return the number 7. So we're looking at row 1, column 1. Row 1, column 1 is right here. Now why he did it column 1, 2, 3, 4 this way, I don't know. Again, that's just the author's preference. That's there. I probably would have done it 1, 2, 3, 4 and return the divide by key right there. And you'll also notice that his code does not match his keypad. That's there. That's an interesting, an interesting observation there, is he shows a picture of a keypad, and then he shows, well, that's there. Hopefully I can get back to the site that I was on. And did I just break my monitor? Right there. Okay. So he's showing a different keypad in his code example than he's showing in the picture. That there. You have to look at our keypad when you write the code. Right there. Actually, I think our keypads don't have anything on them. I think they're just blank. Right there. So in which case you can use this code right here exactly. That's there. It doesn't matter. Again, the whole key of the lab is to show that you can read a key right there, and you know which key you read. So you can use this keypad right here, where you're going to, in this particular case, he would return A. If you use this keypad, he's using this keypad here, so he returns a 7 right there. So it all depends on the keypad. This is where the hardware and the software have to talk to each other correctly, right there. So if you use this code and you use a different keypad, then you have to go back and modify the code to match whatever keypad, right there. And if you wire it up the way I did, you would modify the code again, and you would call this column 1, that there. You would then return the division key, whatever code you give to the division key. But in this particular case, all he's doing here is he's reading the first row right there. And he's saying that he's going to return 7, 8, 9, or divide by, depending on which one that there. So he's going through and returning 7, 8, 9, or divide. Right there. And he's looking at each column. Now, if there's a low on 7, he never looks at that there. So actually, the way this code works, he's going to return the last one. Actually, the return key actually exits the sub, so he'll return a 7. So if you accidentally press the 7 and the 8 together, it's going to return a 7. Because as soon as it saw the 7 was pressed, it exits the subroutine right there. So that there. And then he just repeats this code for the next 4 columns right there. Right there. He just repeats that there. Now, the way that he's wrote this code, he's returning an ASCII character. So when you go through and you test your program using this code, he's going to, here for the number 0, he's returning an ASCII 0. He's not returning a 0 right there. If no key is pressed, then he returns a 0. So this is the whole code for talking to the keypad right there. So you just write a code, and if you're waiting for a key press, you just say while get key not equals 0, and it's going to stay in that loop and keep calling get key until somebody presses a button, and that's what you're going to do next week right there. So you just simply that there. As soon as the key is pressed, this is going to return something other than a 0, and then you're going to just simply put a breakpoint, and you're going to see what key is pressed right there. So it's a relatively straightforward lab. It's just going to use this code right here. So this code right here is what you need to put in next week, and I'll write that up there. So His is his main routine, and right here, what he's done here is he's put this little loop here while not C is equal to read keypad, and he's calling getPad. C is what's returned from read keyboard. C is defined as a char right there, and he's going to then okay, that's there. So what he's done here is he's looping around. Now all this code right here is to write whatever character you send it to the to the display. We're not going to use the display next week, because I mentioned we have a problem with our 5-volt supply, or else we would just use this and combine the two labs together. It'd be nice if we could do that, but instead we have to rely on breakpoints to see what character is written to right there. But all he's doing right here is that he's counting how long it's going to take that there, and he's going to just simply write char C right there, whatever character that's there. Now, the way that he's written his code is that while P is not equal to C, right there, P is equal to C, he's going through right there, and he's keeping track of however many times we're pressing that particular button right there. All we're going to do is simply implement our code while that's there, and we're just going to look at what C is when it returns. We'll just put a line P is equal to C, and we'll just just look at that with the debugger that there instead of worrying about that there. So this is actually the entire keypad press right there. So I'm going to stop this here and just label this recording keypad that there, and I'm going to start another recording. So just give me a few minutes. As I said, my plan is to cover both the keypad and the LCD today. That there, this actually took a lot less time than I thought it would. That there, because it's a fairly simple code. The LCD will take longer. So just give me a minute here. About half an hour. That there. Okay.